Good morning again. It is Tuesday, March 24th, and these are your notes for today. We're going to switch gears a little bit and talk about compound interest, which may seem kind of random, but it's a particular application of exponential functions, and you will see it's going to come full circle. When I attempt to write the notes, the videos always come out too long, and YouTube won't let me upload anything longer than 10 minutes. I don't really want to pay for a premium account, so I'm just going to read along with the notes. These are posted on Classroom for you. It's your choice if you want to copy them or if you just want to follow along with me. So first of all, let's get some vocab out of the way. Definition of interest is a payment either from a borrower to a lender or a payment from a deposit-taking institution like a bank to a depositor. It's of an amount above the principal at a particular rate. So there's a whole bunch of other vocab in here that we need to unpack as well. Principal is the original amount of either an investment or a loan, what you take out from the bank or what you put in the bank. And the rate is how fast something's accumulating. That's your growth factor. So this is a situation where you're either borrowing money from a bank or you're investing money at a bank, and they are either rewarding you for investing by paying you interest, or they are penalizing you for borrowing a loan by having to pay back more than you originally borrowed. So how the interest rate is determined. I am not an economist. I took a couple of, there's my dog. Hi, Hazel. I took a couple of economics classes in undergrad, so here's my very elementary understanding. It's determined by the Federal Reserve Bank. I'm sure you've heard about the Fed in the news. Private banks that compete with one another, and consumer demand. So obviously, if nobody's borrowing money, they'll need to lower that interest rate in order to incentivize new borrowers. And this is all based on something called the Phillips curve, which from my understanding is an attempt to find an equilibrium between inflation and unemployment. As unemployment decreases, inflation actually increases, which means as we have people in the workforce, the value of our money decreases. And it's the entire role of the Federal Reserve Bank to try to find some kind of equilibrium so that unemployment is not too high, but inflation is not too high either. So you want unemployment to be low enough that people are working, but not so high that inflation goes up. If you're curious about that, you can read more about the Phillips curve or Google. I'm sure there's a video on there for you. Anyway, so there's a couple of different types of interest that we're going to talk about. The first is called simple interest, which isn't really used a whole lot in the real world. It's when they calculate your interest only one time per year. The equation is interest equals principal times rate times time. So for example, if you invest $1,000 and they're providing an interest rate of 1.5%, you want to figure out what is your interest or what's your investment going to be after 10 years. You can plug that into your formula. You invested $1,000 at a rate of 1.5%, always converted to a decimal here, times 10 years is $150. So if you invest $1,000 in 10 years, you'll make $1,150 total. Not that great of an investment. So that's an example of simple interest, and simple interest is defined as calculated once per year. Next, we're going to talk about compound interest, which is a little bit more relevant for what we use in the real world. And compound interest means that it's calculated more than one time per year. And if you're calculating your interest more than one time per year, then it actually means that you're earning interest on interest. So if you think about it, you're taking your principal, you're calculating interest, and then when you calculate again, it's including that interest value on top of your principal. So compound interest can occur daily, weekly, monthly, semi-annually, quarterly, etc., etc., etc. And these words will clue you in on the number of times that it's being compounded, aka calculated. So the formula is the amount over time, where time is in years, is your principal, the original amount you borrowed or invested, times 1. That could be like 100% of your principal, plus the interest rate, divided by n, where n is the number of times it's compounded per year, raised to the nt power. So the number of times it's compounded per year, that n, is going to be given to you based on the wording of the question. For example, if it tells you that they're compounding daily, then the number of times they're compounding in a year is 365. N is 365. If it's weekly, There's 52 weeks in a year, so that means n is 52. They're compounding 52 times in a year because they're compounding weekly. Monthly is 12. Semi-annually is twice. It could also mean every other year, which can be a bit confusing, but in this context, semi-annually means twice a year. Last but not least, you could compound continuously. And compounding continuously, you will see this specific word spelled out for you explicitly. It'll say continuously in the problem. And compounding continuously uses the formula amount as a function of time equals the principal times something called Euler's constant raised to the RT power, where P is your principal, E is Euler's constant, R is your rate, and T is your time in years. Euler's constant, sometimes called Euler's number, is based on the calculus principle. It's the limit as n approaches infinity, but for our purposes, it's equal to about 2.718. And the good news is that E is a button in your calculator. So just like pi we use as a constant, we're going to use E as a constant. And it's located in the division sign here. So you'll hit the yellow button to activate the yellow menu, hit the division sign, and you'll see E, which is about 2.71828, etc., etc., etc. Okay, I'm going to jump right into the examples here. Example 1. You deposit $2,500 in a savings account, paying 1.8% interest compounded monthly. So here's our big clue word, monthly. What is your balance after 5 years? So if it's being compounded monthly, that means that we're using this formula. Our n is telling us the number of times that it's compounded in a year. And if it's compounded monthly, it means that n is 12. So I'm going to copy everything here into my formula. The amount after 5 years is going to be our principal, $2,500, times 1 plus. The interest rate is always as a decimal, so I'm going to slide my decimal point 2 places to the left, 0.018, over n, which in this case is 12. It's compounded monthly, so 12 times in a year, raised to the 12 times 5 power. And that entire thing can go right into your calculator. 2,500 times 1 plus 0.018 over 12, raised to the 12 times 5, where I have 12 times 5 inside a set of parentheses here to indicate those belong in the exponent together. And after 5 years, my investment is worth $2,735.25. So I made $235.25 on that investment after 5 years. Not so great, but accurate. Number 2, you invest $5,000 in a CD. CD stands for, what does that stand for? Cash deposit, guaranteed deposit, something like that. It's a particular type of savings account where you put this money in and then you can't touch it. You can't make any withdrawals from it for the amount of time that you agree. So in this case, you put $5,000 in a CD, paying 2.5% interest compounded continuously. So here's that clue word, which formula we need. What is your return on investment, your ROI, in 10 years? ROI, return on investment, is just how much do you make back, basically. So they're telling us that this is compounded continuously, which means we have to use this formula, Euler's constant formula. So my amount after 10 years is going to be my principal, 5,000. E is a constant, raised to the R, where it's always interest rate as a decimal, so move this 2 places to the left, 0.025 times 10. And we can put that whole thing into our calculator here. 5,000. My E is located right by that decimal point, so I'm going to hit divide, division sign, raised to the 0.025 times 10 power. And in this case, after 10 years, My new balance is $6,420, and I'm going to round up 13 cents. But if they're asking us for the ROI, the return on investment, they're asking us how much we made. So I'm going to take that new amount, subtract it from my principal, which means I made $1,420.13 on my investment. It's just the difference between the new balance and your principal. Okay, so your homework is posted on Classroom. You can print it or you can do it on a separate sheet of paper. Looks like this. You do not need to copy down the question. So if you're doing this on a separate sheet of paper, just make sure that you label 1A, 1B, 1C, 1D so that I can follow your work. You don't have to copy the question if you don't want to. They do give you the two different formulas right there for you on that same page. Just make sure that you're looking for the clue words. If you're compounding continuously, you use the formula with Euler's constant. If you're compounding some specific number of times annually, like monthly, weekly, daily, etc., you're going to use the other formula. Sorry, she's barking at something. All right, good luck. Let me know if you have any questions.